One aspect of the modern turbocharged engine has been the possibility of the turbo overheating if misused. That's nearly always by the driver turning the engine off immediately after a hard drive. To overcome this, a liquid-cooled turbocharger has been introduced on the 1985 Audi 205T and will also be installed in the near future on the turbocharged diesel transporter, Golf and Jetta. Chris Goffey has been looking at this latest development.
Now, the whole point of water cooling the turbo unit is to provide a more effective means of dissipating the heat from this small localised area into the whole mass of the engine and its cooling system. Now, it's the dissipation of the heat from the turbo unit that is most critical after a high-speed run. The classic recipe for trouble in a turbocharged engine is a quick blast up the motorway, pull into the service area and switch off. When a family is towing a caravan up the side of the Alp, they turn round and look at the pretty view and switch off. Or when somebody's struggling to get a boat up a slippery slipway, they stop at the top of the ramp and switch off. Now, each time the turbocharger's been working very hard, it's very hot. You switch off and the oil stays in the unit, it fries on the bearings, on the seals and on the shaft, and it carbonizes. And it's this carbonization of the oil which can ultimately lead to turbo failure. The new liquid-cooled turbo now has two ways of dissipating the heat: by oil via the lubrication system and by water via the engine's cooling system. When the engine is switched off, the oil flow stops, but the water flow here continues. An electric coolant pump circulates coolant through the turbo until its temperature has been reduced sufficiently to prevent carbonization of the oil taking place. Now, the system's controlled by an electronic relay which is located down by the driver's footwell. When the ignition is switched on or when the engine is running, the control relay prevents the system operating. But when the ignition is switched off and the temperature of the coolant passing a thermo switch is over 120 degrees C, the switch contacts will close. In this state, 12 volts is supplied from terminal 30, which is permanent live, to the control relay. This triggers the control relay which switches on the coolant pump and the first stage radiator cooling fan. Now, once the temperature of the coolant has reduced to approximately 105 degrees C, the thermo switch contacts open and the 12-volt supply from terminal 30 is switched off. This signals the control relay to switch off the cooling pump and the radiator fan. So let's see how it goes. Well, for someone who's been driving an Audi 200 Turbo very fast, that's a very reassuring noise. Now, I've switched off, but the point is that owner-drivers of these vehicles should be told about the system and what to expect from it.